So we've seen how power series will converge to a function for certain values or certain intervals. But now we want to figure out how can we go from a function to a power series. Okay, how can we figure out what the power series is that represents that function? Well, for starters, we have what we know about geometric power series. We know about a geometric series, that is. We know that if we have this series, the sum of AR to the n, that's a geometric series. We've seen that that is exactly A over 1 minus R. So this is a sum that we can figure out. Remember, not all summations we can figure out. We might be able to figure out if they converge or not, but we can't figure out what they are. Well, in this case, we know this for a geometric series. Well, what if we make this R into an X? And maybe an A into a 1. A, remember, is just a constant here. So if we have that, then we can rewrite this as 1 over 1 minus x, and that means x is our ratio, our geometric ratio, and a value is 1 here. So using what we know about our geometric series, we can write this as this function is equal to the sum of x to the n. The infinite sum, that is. So we have that when x is 0, we got 1, and then x to the first, x to the second, x to the third, so on and so forth. So that pretty simple looking expression, if it is infinite, as a infinite series is, then that will add up to 1 over 1 minus x. All right? So this series will correspond, however, only on the interval of -1 to 1, because this ratio of x, the ratio, we know that this is only true when the ratio is less than 1, or the absolute value. So this is only true when the absolute value of x is less than 1. So between 1 and 1. So if we want to center this series on a different value, well, we could take a different number like c equals 2. And we could rewrite this so that we have an x minus 2 instead of an x there. So we can rearrange it. So let's explore that a little bit. All right, so here's a little exploration. So the idea is this. We want to rewrite this, which is centered at 0, okay? And we want to rewrite it so that it's centered at x minus 2, or centered at 2. So we can rewrite this as, if we put an x minus 2 in there that we want, if we subtract 2, so what happened here? So here we took and we want this to be an x minus 2. We want that in the mix. And this is really adding a 2, and so we need to subtract a 2. So simplify this bottom, and you'll convince yourself that that is really 1 minus x. It's equivalent. Okay, well, let's get a little creative, and we want to rewrite this so it's in this form: a, some number, over 1 minus r. Okay, so we want this to be 1. Well, let's clean this up a little bit here. All right, now we don't want to completely simplify it because we know it simplifies to 1 minus x on the bottom there. But if we clean this up a little bit, we can rewrite this as, this is 1 over, and let's combine this 1 minus 2. That's -1 minus x minus 2. Now, we want to leave the x minus 2 in there because we want this to be centered at 2. Okay, well, we got a -1 in the mix here. We don't really want that. We don't want that to be -1. We want that to be +1. So what can we do? Well, we can multiply or divide by -1. All right, let's divide by -1 on top and bottom. All right. So if we divide by -1 on top and bottom, that's going to give us -1 on top. And we're going to divide both of these terms, there's two terms, by -1. So we end up with 1 plus x minus 2. So again, we want this to look like the form a over 1 minus r. And it's close. We've got a number up top here, constant that is. We've got a 1 in that 1 spot. We want this to be minus. Well, let's get a little creative. We can say this is really -1 over 1 minus negative x plus 2, or x minus 2. Okay? Well, what's the story there? Why do we do that? Well, we have now A equals 1 minus R. So that gives us our A value. So A is negative 1, and R is going to be negative x minus, I put a C there. That should have been a 2, huh? All right, so this is going to be negative x minus 2. All right, so now with that, we can write this as the series negative 1 over 1 minus negative x minus 2 is equal to the series from n equals 0 to infinity of negative 1 times, and we've got negative x minus 2 to the n. So here's our geometric series. We've got our radius to the n power times a. And if we wanted to clean this up a little bit more, we could say this is 0 to infinity of negative 1 times, well, let's distribute that negative. This will be 2 minus x. A little cleaner looking. All right, so there we have it. So this should match 1 over 1 minus x for a radius of x that is less than, no, we want it's going to be centered at 2. It's going to be less than 3 and greater than 1. Okay, so we're going to have a radius of convergence of 1 centered at 2. So see how 2 is at the center here. Well, let's graph it. Let's see how that works or how that looks. So if we get Desmos going here, we've got 1 minus x, looks like that. Okay, and we said we got the sum of negative 1 times 2 minus x. Okay, so we can do the sum, and under functions here we should have a summation here. There it is. N equals 0 to, now we can't put infinity here, but let's put a large number here. And we have, I don't know if it needs those parentheses or not, but we'll do that. And negative 1, and we had 2 minus x is what we simplified it to, right? 2 minus x. 2 minus x. And we'll raise that to the n power. Okay. So there we have it. What happened? Okay, so you see this matches really good, okay, between 3 and negative 1. It's a real good match, but then at 3, it just explodes in the negative direction. It doesn't match. So we have a perfect match for everything from negative or positive 1 to 3 for all those x values, all right? So that's how we can get take a series and use that geometric series representation to represent a function, all right, if it's in that form. Well, what if we have something that isn't quite in that form, a over 1 minus r? What can we do? Well, here we have this function, 4 over x plus 2, and let's see if we can get it in this form. Well, first step is to rewrite this as, let's see, we got 4 over x plus 2. Let's rearrange it a little bit. Okay, we know we want the x to be in the r. A is going to be a constant here. Okay, what would you like this to be here? You'd like that to be a 1 probably, right? So let's take this and let's multiply by a half. Okay, we can do whatever we want to the top and bottom, as long as we do it to both top and bottom, right? Make sure you distribute that half. So this is 1 plus x over 2. Again, we want it to be as a constant over 1 minus r. This is not a minus, but we could rearrange it, get a little creative. And this is 2 over 1 minus negative x over 2. We now have a over 1 minus r. So the a value is 2, and the r value is negative x over 2. Okay? All right. So there we have it. We'll copy that down. A is 2. R is negative x over 2. Okay, so our geometric series is this. So 4 over x plus 2 is equal to, let's see. This will be from n equals 0 to infinity. That should be an n. And we're going to have our a value, 2 times negative x over 2 to the nth power. Well, now we want to find the radius of convergence. Okay, so we have this nice series here, but it'll probably not match everywhere. Okay, so let's find our interval of convergence. So let's use our ratio test. So our ratio test says that we want to find the limit as n goes to infinity. We have the absolute value of the n plus 1 version, 2 times negative x over 2 to the n plus 1, all over the nth version, the nth term, negative x over 2. Let's make that to the nth power there. Well, we have the same term here. The 2's will cancel. And this is going to give us the limit as n goes to infinity of, well, we'll subtract it here. We get n plus 1 minus n. That's going to be 1. So we'll have that negative x over 2 to the first power. And that negative is going to go away. And so this is going to give us x, absolute value of x over 2. And that's going to be, we need that to be less than 1 for the ratio test. Okay, so that means that x plus x over 2 is less than 1, or negative x over 2 is less than 1, because that's the absolute value. Multiply both sides by 2 here, and we get x is less than 2. If you multiply both sides by 2 here, we get negative x is less than 2. All right. And if we divide by negative 1, then x is going to be greater than negative 2 here. So what does that tell us? That tells us that our radius is going to be 2 equals 2. And we know that x is less than 2 and greater than negative 2. So now we just converted the rational function here into a series. That would be a perfect match between negative 2 and 2. All right. Now here's a quick interesting observation here, okay? If we use longhand division, we'll get the same thing. So watch what happens here. All right. If we take 4 divided by 2 plus x, so 4 divided by, got to remember our longhand division here. Whoops. Let's go 4 divided by 2 plus x. All right. Now, let's see. We're going to have to multiply this by 2 to make the first term match. That gives us 2 times 2 is 4 plus 2x. And we subtract these. That's what we do in longhand division. So we get negative 2x. Now we need to make that match, so we've got to multiply it by negative x to make negative x times this. We want this to match because we want this to go away. So remember, in division, we're trying to make that go away. Negative x times 2 is negative 2x. Negative x times x is negative x squared. So if we subtract those, we end up with x squared. Now we ask ourselves, what do we need to multiply this by to get x squared? Well, we need to multiply it by a 1/2, right? So we need to this is a 1x, so we need to multiply it by a half to make that 2. 1/2 times 2 to become 1. And then I need this to become x squared, so I need to multiply by x squared. So x squared, that gives us 1x squared. 1/2 x squared times that x gives us 1/2 x cubed. And we'll go one more step here. Okay, now I need to make that, let's see, what happened? That was a squared. Let's subtract. And when we subtract that, we get negative 1/2 x cubed. And we say, okay, what do I need to multiply this by to make this? I need negative 1/4, right? Negative 1/4 times 2 will be negative 1/2, and I'm going to need x cubed. Okay, and if I multiply this by this, then we'll get, running out of room here, squeeze it in there, that would be negative 1/2 x cubed, which would match, minus 1/4 x to the 4th, and ... we could continue. All right, well, what's the moral of the story here is this. If you notice, what is this series? Well, this is the series that we got up above. The series is n equals 0 to infinity of 2 times negative x over 2 to the n. When n is 0, this becomes 1, and we just end up with 2. When n is 1, plug in 1 here, you can have negative x over 2 times 2, that's negative x. When n is 2, we're going to have positive x over 4 times 2, that's 1/2 x squared. Okay. Plug in 3, you're going to get this term, so on and so forth. So this is equal to that. All right, so longhand division will also get us there. Okay. Well, let's look at another power series here. So we want to find a power series for this centered at 1. Well, in order to do that, we can rewrite this a bit. We want it to be 1 over 1 minus something. Well, 1 minus what? Well, 1 minus 1 minus x. How about that? That would get us there, right? Okay. Or you could call that negative x plus 1. And now it's in that form, a over 1 minus r. So a is 1, and r is 1 minus x. All right. Okay. So we now have our series 1 over x is equal to the sum of n equals 0 to infinity, and we have 1 times 1 minus x to the nth power. To see what's going on here a little bit better, we actually want to rewrite this like this. Let's rewrite this bit as negative 1 times x minus 1. Okay. Why would we want to do that? Well, when we raise that to the nth power, that's going to be negative 1 to the nth times x minus 1 to the nth. There we go. Okay, and what does this look like? Well, this looks like when n is 0, we have x minus 1. Actually, with the whole thing, when n is 0, the whole thing becomes 1. So 0 here and 0 here, we get 1. When n is 1, we have a negative, so we're going to be minus, so it's going to be alternating. This shows us our alternating is what this does. And we have x minus 1 to the first power. When n is 2, then this becomes positive 1, so it's plus x minus 1 to the second power minus x minus 1 to the third plus x minus 1 to the fourth, ... Okay? So there we have it. So we now find out that this is equal to 1 over x. So we now have a power series for 1 over x. However, this is centered at 1, and to show us that, we can do our ratio test. our ratio test says this. We're going to take the limit as n goes to infinity of negative 1 to the n plus 1 over x minus 1 to the n plus 1 all over negative 1 to the n and x minus 1 to the n. All right, and so this is going to give us the limit as n goes to infinity. We can actually just get rid of these negative 1s because the absolute value. This is the limit of x minus 1. And so this is going to be equal to absolute value of x minus 1, which is less than 1. All right, so this is centered. This is going to be everything with a radius of 1. So this is our radius here, 1, centered at 1. Okay, so this is going to be everything. You can write this as x minus 1 is less than 1 and greater than negative 1. If we add 1 all around, okay, then we end up with x is less than 2 and greater than 0. Okay, so our radius is 1. So this is everything from 0 to 2. So it's centered at 1. 1 is at the center, right in between 0 and 2. So there's our very useful series there for 1 over x, but it's only good on 0 to 2. So that's how we can use what we know about a geometric series to find a power series for a rational function that we can get into that a over 1 minus r form.